Hi, so today we're going to keep working with OpenCV and Unreal Engine 4. Last time we got OpenCV integrated into the engine. You can see most of our code up here. We're taking care of that. And now we're going to add a few things to our build because we need access to a few classes that we won't be able to use without adding some of these to our modules. And we'll get that built. And the first thing we're going to do is set up a camera reader class. So in your Unreal project, make a new class, actor. You can call it whatever you want, but I'm going to call it camera reader. We'll start setting up our header file by adding our includes. So we need our OpenCV, our media texture, texture 2D, and texture render target. For the constructor, we're going to need the object initializer. So add that. For our components, we'll need a scene component and two static mesh. The scene will just be our root component, and then for our static mesh we'll have two screens, one for our raw camera footage and one for our post edits after we do stuff with it with OpenCV. We're also going to need quite a few camera properties. This will be our camera ID, the track ID, refresh rate, refresh timer, and then our brightness and multiply. We'll be using those in OpenCV to affect the camera's post. For the camera properties, we're also going to want a bool to keep track of whether it's on and the video size we're getting in. And then we're also going to want some pointers to a bunch of assets that we're going to create within the engine. So we're going to make a media player, a media texture, a render target, two materials, and then we'll generate this texture 2D in code. We're almost done with the header file. Just need a few more things. We're going to want a function. This is just going to be so Blueprints will know when a new frame's been called. We're not actually going to do anything with it. It's just for functionality later. And then read frame is where most of the magic's going to happen. This is where we're actually going to read the frame from the camera input, send it to OpenCV, do our post edits, and then send that back to the other screen. And then here we just have a few storage classes for OpenCV, the size of the video stream, and then our actual image reference right here. So that's it for the header. There's quite a bit. There'll be a link in the description to the website where you can grab the code, so don't worry about it. Next we'll start filling in the C++ file. So we're actually going to want to add object initializer, add that, make the call to super, and then for our constructor we're going to make our components. So we have our root component and our two static mesh component. We'll set the default brightness and multiply so they don't actually do anything. That's brightness will have no effect and multiply will have no effect by default. Our camera ID we want to be 0. Our video track ID we also want to default to 0. For most people, that should be okay, but you might have to change your camera ID to your preferred camera depending. Default the stream open to false, it doesn't start open. And for us, we're going to work with a 1920 by 1080 camera by default and set the refresh rate to 30. So that's our target refresh. Begin play is pretty easy. We're just going to initialize a few things. So we'll let the game know the stream's open. We'll initialize our color data array. I'll also set up the OpenCV size and initial image. And then we'll create that texture 2D I was talking about in the header. And then lastly, for begin play, we're just going to set the bitmap, so we don't want to generate anything because this texture is being made every frame, so we just want the one. And then for the camera render target, we'll match the incoming sRGB value of the render target that we set with the texture 2D. Tick's even easier. We basically just count down through our timer, and then if it is time to refresh, we'll call the next video frame delegate for blueprints, and we'll read the frame. For our last function though, things get a bit more complicated. This is when we actually read the frame. So this imshow function down here from OpenCV that's giving us an error, we could either comment it out. We don't really need it, but it is helpful for debugging if we have any problems. It'll open up an OpenCV window, which will show us the output we're supposed to be getting from OpenCV onto our post screen in Unreal. So if we want to keep it, we just got to go back to our header file, and there's another include from OpenCV we need. We need this high GUI include. And if we save that, that should take care of that. You can also just comment it out. Like I said, we don't actually need it. It's not providing any functionality. It's just for a visual and help you debug. Now for the actual function. Here, we forgot to assign our pointers. We're just going to return. Probably do a bit better error checking there, but that'll get us through for now. And then we'll get a pointer to our render target and read the pixels. We'll assign that to our OpenCV, and then we'll do any conversions we want. So that's why we have our multiply and our brightness here. So if you want to do any other conversions to the image with OpenCV, right in here is where you're going to want to do them. And then we show the image as I was discussing on OpenCV there if we want. We can get rid of that if we want though. Then down here we lock the texture so we can read and write to it if we want. We're going to store the size of the data, so that's going to be every entry in our color array times by 4 because there's an RGBA slot for each one. And then here we actually write to the data, unlock, and update the texture resource. So that's going to be it for the C++. You can go ahead and build your file, but we still have quite a few things to do inside Unreal Engine itself. I know some people don't like blueprints, but there's a few things we have to set up in them. So yeah, go ahead and build your file, and we'll see you inside the engine. Once your project loads, you want to make a child blueprint of your camera reader class. Call it whatever you want. I usually add a BP to the end of my blueprints. And if you don't have a spot, you'll probably also want to make a folder to put it. Then if we take a look here, we have our media player and texture that we need to create the assets for and fill. And we're also going to have to make some materials. This guy gets generated automatically, so we'll just minimize that. Media, we need our media player, and yes, we do want the media texture. And then we're also going to need a material, camera raw, and another one, camera post. We need to make one more thing. Render target. Camera render target. So we open them back up our BP. We'll assign the media player, the texture, and the render target. Compile, save that. Open up camera post and camera raw. Camera raw is really simple. Just grab the texture from your media player and send it out to emissive. Save that. For a post, you'll want to make a texture sample 2D. Name it. You'll need this name later, so make sure you remember it. And we'll take that and also send it to emissive. Save it, and that's all we got to do to the materials. Open up your camera reader. We're going to need the full blueprint editor now. We can add some planes to our mesh, so we actually have something to render onto. Same thing for this one. Add a plane. You'll probably want to move one of them over because right now they're both right on top of each other. Now in the event graph, we can get rid of this begin actor overlap, and we'll add calls to our super or parent function on both begin play and tick. Now we're going to create our two material instances for our camera screens. So create dynamic, and we need one for raw, and another one for our post screen. We want to make sure we're setting these materials when we make them to our pointers. So set camera mat raw, and for this one, set our camera post. Make sure we're setting them to the appropriate materials. So post, raw, and that's the first part of our begin play. Next we'll tell the media player to open, so we'll grab the media player. And we need to enumerate our video capture devices. We'll select the device based off of our camera ID. We'll get the device by ref based off of our camera ID variable. So get camera ID. And break that. So that we can open the URL from it. Media player. Open URL. Try to keep your blueprints organized. They can get out of control fast. One last thing for our begin play function. We need to set our texture parameter in our post camera material. So we'll get our camera, map post, and we want to set texture parameter. And that'll be whatever you name that texture parameter, in my case texture. And you want to set it to our texture 2D that we're generating so that it'll actually display the changes. That's it for begin play. Now for tick, we just need to draw to our render target from our raw camera. Because the render target's what's passing the data to the texture and OpenCV. So we want that to be our raw camera. And just make sure these are valid. And we'll quickly come back here. And I just want to add a delay. Find this texture doesn't always load properly if we don't put this delay in here. So compile, save. Should be good to drag out your camera. Just rotate it. And hit play. Now if you get a black screen like that, it's all good. Just open up your media player. And then make sure you got the right camera. So if you have other cameras, they'll show up here. And then one of the trickier things is sometimes there's more than one video track. So in my case, I have to select the other track and hit play. And there we go. Now, we didn't actually apply any post effects to the other camera yet, so we'll quickly change the multiply to 2. Brightness, let's say -20. Hit play again. I gotta set the track again. That's why I set the video track ID property. In my bigger project, I have that set up in a function. There, now we can see the difference between the OpenCV and our regular feed. So yeah, if you're getting that black screen, just remember to check that you're using the right video track. Cool, so that's it for this video. We'll see you all next time.